Welcome to our tutorial How to use R for Research. In this session, we teach you correlations in R programming. What correlations do? Correlation measures the intensity of the relationship between two variables. But you should bear in mind, correlation implies association, not causation. It only means X associated with Y, not Y decreased or increased by X. The data that we use today is available in this link. It is laifactors.csv file. After downloading it, we load the CSV data. Simply, we can use core function to display correlation. Let's say, for example, core LAI India column with the LST India. The method equal person correlation. It is minus 0.5. We have the function of cov, which is abbreviation of covariance. For using person's correlation coefficient, we can use core.test function, the first variable and the second one. Method equal person. We have degree of freedom, p-value, not significant, correlation estimate, minus 0.5. Instead of person correlation, we can choose Spearman method. Spearman's run correlation coefficient, RHO, RHO in brief, core test between LLI and LST of India. The method equal Spearman. P-value 0.01, it is significant, and RHO equal minus 0.58. Also for correlations, we can choose tau, core test, the same variable, method equal Kendall. The correlation is significant and tau estimate minus 0.41. We can name the output. Let's say PE, core.test, LAI and LST of India, method equal person. After that, going to extract p-value and correlation. P-value of PE. Now only we extract p-value of correlation. In the same way, we can extract correlation coefficient R by using the name of the output PE, $, and estimate. In the same way, we can use Spearman, extract p-value, and extract RHO correlation. Also, we can use Kendall, then extract p-value and extract tau of correlation. In general, correlation is close to O, value close to O means there is no association between two variables, while minus 1 indicates that a strong negative correlation is available between them, while plus 1 or close to plus 1 means a strong positive correlation is available between two variables. Based on our tested result, a significant relationship available between LST and LLI in India. Let's perform correlation between some simple values. For example, core.test between two groups. At the beginning, we put the same value for two groups, two variables, 1, 3, 5, and 7. Method equal person. It is significant and R equal 1. Using Spearman, the result is not significant, and RHO correlation equal to 1. Using Kendall, if we change, let's say, only one value in the second group, we change the 7 to 4 to test how it's changing. Now, the R correlation coefficient from 1 changed to 0.83, and in Spearman method 0.8, and in Kendall method 0.66. To find matrix correlations with the significant level, we can use rcore from HMISC package. This package should be installed. Then we calling the library. Now we use rcore function from this package to find as matrix df and method type equal person. That's the output. We can change the method to Spearman. Let's take another example. Try to find correlation between IQ score and hours spent weekly to watching TV. IQ equal these values and TV time spent equal this value. Cordon test between IQ and TV, method equal person. Then change method to Spearman and Kendall. We can see the correlation is not significant, and only significant correlations should be considered in the research. So based on these values, no significant correlations found between IQ score and time spending for watching TV. That's the end of today's session.